Hey Team Bio! So today in class we talked about entropy and osmosis, and we defined osmosis as the net movement of water through a semi-permeable membrane. And today's screencast is going to be pretty brief. I'm going to just be talking to you about a bunch of different situations that cells can find themselves in, and what happens to the movement of water across the membrane. Okay, so our first situation, we have a cell that has a higher concentration of salt inside the cell relative to outside the cell. So we have a higher concentration of water outside of the cell. This is called a hypotonic solution. When a cell is immersed in a hypotonic solution, remember, ions cannot cross through the semi-permeable membrane, only water can. So water is going to rush into the cell, and the cell is going to get bigger. However, if the concentration difference between the inside and the outside of the cell is great enough, we can have something terrible happen to the cell. It can burst open. This is called cytolysis. The cytoplasm inside of the cell lyses or comes out of the cell. The cell bursts and the cytoplasm escapes. So, unfortunate ending for a cell immersed in a hypotonic solution. Our second situation is exactly the opposite. Now we have a higher concentration of salt outside the cell and a higher concentration of water inside the cell relative to outside. This is what we call a hypertonic solution. In this situation, water is going to rush out of the cell, and the cell is going to lose mass. It will shrivel, and this is called plasmolysis. And the last situation is our Goldilocks situation. We've got equal concentrations of salt and water inside and outside of the cell, and this is called an isotonic solution. In this case, water is still coming into the cell, but it's balanced by molecules of water leaving the cell. So on net, there's no change in mass of the cell. This is called dynamic equilibrium. Okay, different types of cells prefer to be immersed in different types of solutions. If we look at this figure down here, you can see that the animal cell, when it's immersed in a hypotonic solution, splits open, it lyses, the cytolysis. And here, when it's in a hypertonic solution, it loses mass and shrivels, plasmolysis. It's happy in an isotonic solution. So we can put a little starburst around this here. Animal cells prefer to be in isotonic solutions. If you have a severely dehydrated person who needs more water, you would never want to inject water directly into their veins because their red blood cells would all start to burst and you'd kill them. So you want to rehydrate them with a salty solution delivered in an IV, not a water solution or just water, straight water. That would be bad. Plants, however, prefer to be immersed in hypotonic solutions always. If they're in hypertonic or isotonic solutions, they start to wilt and kind of flop over. Immersing a plant cell in a hypotonic solution gives it turgidity and causes kind of that, it adds to the structural rigidity of the plant. And you know a well-watered plant when you see it. it's standing upright. So plants prefer to be their cells to be immersed in hypotonic solutions. Is there anything else I want to say to you guys? Oh, I guess the reason why a plant can withstand immersion in a hypotonic solution is because they have a cell wall that's preventing them from lysing in these solutions, whereas animal cells don't. Okay, that is all. See you in class tomorrow.